Hey everybody, your Friendly Math Tutor here, and in this video I'm going to solve a practice module, a full SAT practice test essentially. In this video I'm going to do the first module, which is 22 problems, and then in the subsequent videos I will solve the Module 2 easy version and the Module 2 hard version. So let's get started. Here in number 1, we have a system of inequalities, so I am going to use Desmos. So let me jump over to Desmos, and I'm just going to put it in as is. So y is greater than negative 3x plus 5, and then the second one is y is greater than 2x. And the question asks which is a solution. So I'm just going to start putting them in. I'm going to do 1 comma 4. And I get my answer because let's remember when you are, let me move this over, sorry, so everybody can see. When you are solving a system of inequalities, the one is the red, the other one is the green, and then the solution set is the intersection of both colors. So this point 1 comma 4 is clearly in that intersection, so that must be the answer. So we jump back here, and the answer is A, 1 comma 4. You could go through plugging these in. I just thought it was really easy to just get started with Desmos because, again, we just type it in and you could figure out exactly what it is. Okay, let's keep going. So here in number 2, we have a system of equations, and we could use Desmos, but I am going to choose to do it a different way. And this is really, again, throw it into Desmos and add x plus y. I totally get that. But I also want to kind of go through different things to look for that could save time. And look what happens if I simply just subtract these two equations. 3x minus 2x is x. And negative y minus negative 2y is negative y plus 2y, which is plus y. And 11 minus 2 is 9. And you just get the answer. That is not always going to work, but it's just things to look for. It really is, the best way to earn your highest possible score is a combination of little shortcuts versus doing it the regular way versus using Desmos versus checking answer choices and all the different things that you can do. So honestly, this one, if you see that, you get the answer immediately by just doing 11 minus 2, which is going to be quicker than typing into Desmos. But if you don't see that, you don't want to spend too much time looking for a shortcut because it's no longer a shortcut. So if you're comfortable with Desmos, systems of equations like that, just use Desmos. All right, moving on to number 3. So if A is a solution to this and A is greater than 0, what's the value of A? Again, you can throw this into Desmos, but if you remember how to solve absolute value equations, there's 2 equations to solve. But since they're asking for the positive value, I'm just going to solve this one, the one that you just don't need absolute value for. So I would quickly get 2x equals 14, and then obviously x is equal to 7. And that's our answer. Now, the other one would be to set 2x minus 3 equal to negative 11 and solve that. That would give you a negative answer, but they just want the positive answer. So if you did use Desmos, you would plug it in as is. You would see 2 vertical lines, and you would take the one that goes through 7 because that's positive. All right, moving on to number 4. We have we're still in the level 1 easy problems here. And what we have is an exponential model, and they want the meaning of 25. So in an exponential model, what you have to know is that this value here, it's kind of like the a, if we think of it as ab to the x, this is the initial or the beginning or some starting value. The decimal here represents some percent increase or decrease, but we don't need that in this problem. So if we look at what t is, this model represents the cost of this new piece of equipment after t years. So this is just going to be some like initial cost. So it's not the number of years. The value of the equipment, not after the first year. That's when you would be plugging in 1. That's not the initial. The number of years, nope. The value of the equipment when new. So brand new. When it's the y-intercept. It's when the input is 0. So the answer is D. All right, moving on to number 5. We are still in our level 1 problems. The radius of a right circular cylinder is 6 inches and its height is twice the length of the radius. What's the volume of the cylinder? So if you go to the reference sheet, the volume of a cylinder is pi r squared h. So this is pretty straightforward. We just got pi. The radius is 6, so I'm going to get 6 squared. And its height is twice the length of the radius, so my height is 12. So all I'm doing is 6 squared times 12, so 36 times 12. I'm going to use a calculator for that, and that gives me 432 pi, and that is just answer choice C. Do not multiply by pi unless you see decimals in your answer and not pi. So again, using your answer choices to help guide decisions like that. All right. Okay, now on to number 6. We got a two-way table here. It says if a customer who purchased unsliced bread, so only someone who purchased unsliced bread. So of this two-way table, we are only looking at this column. So of the people that purchased unsliced bread, right away we're down to 180 that we're even looking at. What is the probability that the customer has purchased whole grain bread? Well, of this column, these people purchased whole grain, which is 84. And don't worry about reducing it because look at our answers, and that is answer choice B. All right, so we got conditional probability going on there. All right, moving on. We are now on number 7. So we've got it still. We're still in like our level 1 easier problems stretch of this practice module. A group of friends are eating at a diner. Each entree costs $5.25 and each soda costs $1.50. D people order an entree and P people order a soda. Which of the following is the total number of dollars paid? This is pretty straightforward. We just got to keep our variables straight. So an entree is bought by D people, so it should have 5.25 D in it. So these are gone. And then there should be a 1.5 P for the number of sodas. And it makes sense if we want the total number of dollars paid that they would be added together. All right, so pretty straightforward problem. You got to watch out for these problems, though. You have no idea how many people could pick C accidentally, and obviously they understand. We all can understand this problem. It's not that. It's when it's a time test and you're reading too quickly and you're just breezing through problems, just mixing up. Especially, if we were doing this problem ourselves, we might make entrees E and sodas S. But they decide to just use random letters, again, to really make sure that we're paying attention. All right, let's move on. In number 8, they are testing our ability to evaluate a function using a graph. Again, this one is not too difficult. I am going to try to zoom in a little bit just for this problem. And what's here, we got G of 2. Well, functions are input and output. So what's inside the parentheses here is our input, which is our x. So I go over here. That's where x equals 2. And if I want to know my output, I go up to the graph here. And then I just need to read that y value, which is simply just 8. All right, moving on to number 9, which I believe, no, we actually have a couple more easy ones. So two more, I believe, are easy problems, and then we start to get into the medium and the hard. So again, this is our practice module number 1. Number 9. If the solution to the equation is a positive whole number, what could be the value of k? I think what you could do is certainly use a Desmos slider and just choose values of k. But I am going to do this. I am going to just first subtract the 98. So 1,122 minus 98, and that's 1,024. So kx squared equals 1,024. And then what happens is if I were to get x by itself, I divide by k, and then I take the square root, and I would need it to be a positive whole number. So I'm just going to run through that really quickly. So I'm going to do 1,024 divided by 2 is 512. Well, I know 512 is not a perfect square, so that's a wrong answer. Then I'm going to do 1,024, and I'm going to divide by 4, and that gives me 256. Well, 256 is a perfect square. The square root of 256 is 16, so that must be the answer. All right, and then these are wrong because, again, if you do 1,024 divided by 8, you get 128, and 1,024 divided by 32, you get 32. They are not perfect squares, so when we take the square root of them, we will not get a positive whole number. Again, if you chose a Desmos slider and made k each of these values, you'll see that the only one that gives you a positive whole number answer is answer choice B. All right, I just found it really easy to just use my TI-84 and run through these really quickly. All right, the last of our easy problems. So we want to know which one is equivalent to this. This is a pretty straightforward equivalent expression problems. These can get trickier, as we will see later, and then when we get to the hard module. But this one is pretty straightforward. You could use Desmos. You could throw this in and throw in the answers and see which graph lies on top of this one. But I think this is best done by knowing how to factor quickly. There really is no substitute for factoring quickly at any level of math at this point. So here we have two values that that multiply to 8 and add to 6. So that's going to be plus 4 plus 2. And here we have two numbers that multiply to negative 8 and add to 2. So that's minus 4 plus 2. That's my bad. I think I'm the one who's having an issue with the factoring. Because we want to get positive 2. So that should be positive 4 and negative 2. So I will get the plus 4s are going to divide out, and I'm going to be just left with x plus 2 over x minus 2. So that's the answer. That is our equivalent expression. All right, now we get into our level 2 problem. So we're going to have a little stretch here of medium difficulty problems. So here we have an equation that we're solving where a is 4 and we want x to be less than 0. Another one where you can use Desmos, but I am going to choose to just do this like this. If a is 4 and I bring it over to the other side, I get equal to 4. I'm just going to square both sides. So x squared minus 9 is equal to 16. Then I get x squared equals 25. So then I know x is either positive 5 or negative 5. But the thing is, they're telling me x is less than 0. So I know x is negative 5. And be careful, it's not this. They then like to pile on with the number of things that we have to do. They want the value of x minus 5. And negative 5 minus 5 is negative 10. All right, so you just really have to look out for this kind of stuff on these SAT problems. All right, moving on to number 12. So earlier I did a systems problem where I was able to just subtract the equations and get the expression that it was looking for. But this case, I don't really see a way to do that through addition or subtraction. We could do the substitution method, but I think this one is definitely a perfect candidate for Desmos. So I'm going to hop over to Desmos here, and I am going to throw in y equals 3x plus 2, and then I am going to do 5y equals 13x minus 14, and then we are going to just try to find the intersection. Don't worry about it. You don't really have to zoom in here. Just click on one of the lines, and a point will highlight. And I'll move this up here and do it again. Just click anywhere, and then you are going to have a point highlight. That will be the intersection. Don't worry about like zooming in too much or going crazy with that. So now I know the intersection is -12, -34. So I hop back here, and I'm going to write that down, -12, -34, and then I'm going to do what it says. My suggestion is to do this in the calculator. So I'm going to do -12 minus parentheses -34, and I'm going to get 22. I understand that all of us are capable of doing -12 minus -34 is -12 plus 34, which is 22. I just urge you have the calculator. Use Desmos when necessary, and always have your TI-84 right there. And let it do this kind of math. Let it reduce fractions for you. In general, I think mental math is fantastic, but for this particular test, you want to avoid those silly mistakes because you have no idea how different just one or two questions can make your score, especially if you're right on the cusp of getting the hard versus the easy second section. I have done this problem with students before. They have done it on Desmos. They got the right intersection point, and they give me some answer like -46 or -22, and it's not because they don't know how to add and subtract. It is simply because of just these mental errors. We're all human. So again, when you have something like this, just use the calculator. I normally don't give it advice that way, but for the SAT, I think it's really important to just avoid these like silly mistakes. Okay, number 13, we have a graph here, and it wants to know for how many values is it equal to 2.5. All right, so we talked earlier about input and output. Now they're giving us the output. So an output is a y value, which is 2.5 is right here. So what I like to do is just imagine making my bad. You'd have to imagine it because you don't have the ability to draw on it the way that I do right here. So you're going to be looking at the screen on your actual test, and you're just going to imagine making a horizontal line across. And you're going to say, well, when is it 2.5? It is here, it is here, and it is here. That is 3 different values, so the answer is simply just 3. All right. Number 14. Here's another one where they're really trying to get you to waste time. You could distribute and do a whole bunch of work and find TS, but this is one that I am just going to use Desmos, and it wants S, which is Y. All right, so I'm going to go over to Desmos, and I am just going to plug that in as is. So literally, also, I'm not going to plug it in as is. This might be obvious to some of you. I am going to change the T's to Y's and the S's, the T's to X's and the S's to Y's. Just because they mentioned the T first, so I'm going to make that X, and then I'm going to do Y minus 3 equals 8. That is simply because Desmos with the coordinate plane is, in this case, is really only going to recognize X's and Y's. There is a way to kind of change that, but it's not really worth doing. Then you're just kind of like doing extra work for no reason. So simply, anytime you want to use Desmos, make sure you're using X's and Y's. And again, in the SAT problems, they like to change the letters around. So just, pick one to be X and pick one to be Y. So here we have the intersection 3, 8. So again, I'm just going to jot that down, and then I'm going to say, okay, what's the value of s? Well, s is y, so the answer to the question is 8. All right, moving on to number 15. So the given expression is equivalent. All right, so we have a little bit of a higher level equivalent expression problem. What's the value of c plus d? Now, I am going to do this in the quickest way possible. If you want to completely distribute these negatives and simplify the full expression and then match up, do it that way. But I'm going to skip the x to the fourth and the x to the third. I only care about the x squared and the x term. So I'm going to look at x squared. My x squared term is going to come from this term and this term. And what that's going to be is 4x squared minus x squared, which is 3x squared. So again, I don't really care about these because they don't ask me about a and b. Then I am going to find my x term, which only comes from here. But this negative has to be distributed. Oh, wait. I hope everybody is realizing the mistake that I made. I'm actually glad that this is happening because I'm just running through this test with no edits or anything. So I'm making mistakes along the way. The key isn't to make no mistakes. It's to kind of catch your mistakes. And one of the common mistakes is to forget to distribute a negative. I always have that in my head, and I just missed it. But then luckily it kind of came back to me. So if I only care about the x squared term, that's this one and this one, but this is really a negative 4x squared. That's what I just missed. So negative 4x squared minus x squared is negative 5x squared. So hopefully those of you watching this the first time caught that and were wondering what I was doing. So then now when we jump to this one, and the reason that I caught it is because I was going to do it with this one and I realized I didn't do it with this one. So now I have to distribute the negative here. So this is like minus negative 8, which is like plus 8x. So now I know c is negative 5 and d is 8. And negative 5 plus 8 is 3. So that is the actual answer to the problem. All right? Again, I call this zooming in on the problem. So instead of worrying about the x cubed term and the 5x to the fourth, I just zoomed into what they were asking for, so I only figured this part out. If you want to do the whole thing and that helps you, then do that. But again, I'm trying to do these as efficiently as possible. All right, moving on to number 16. So here we have a polynomial graph, and g of x is this f of x plus 2. What must be true of g of x? So what that means is that it's this graph shifted up 2 units. So I think what I'm going to do with this one is I'm going to use the answer choices to kind of help me decide what's true. So let's start with g of negative 2 equals 3. Well, g of negative 2 is going to be f of negative 2 plus 2. Well, f of negative 2 we don't really have. It doesn't give us. So that doesn't really make any sense. So that can't be true. G of 0. Well, this is going to help me check both of these. So f of 0 is 3. And if I add 2 to that, I get 5. So this one is wrong. And then I need to check this one, because if this is true, I need both of them to be true. So now g of 1. Well, that's f of 1 is negative 2. And negative 2 plus 2 is 0. So this one works out for both. So C is the answer. So for that one, I think it's good to just strategically work through the answers, figure out which one has both of them true. And also keeping it straight that this is the graph of f. So we need to use that first and then add 2. Okay, number 17. What is the value when 80 is increased by 200%? A couple different ways to do this. I'm going to do it the way that I always like to do percent increase or decrease is I think about when if you multiply by the number 1, which represents 100%, nothing changes, right? Anything times 1 is itself. And if it's a percent decrease, I change the percentage to decimal form and I subtract it from 1. For instance, if something is a 20% decrease, I think of that as 0.8. And then if I have a percent increase, I add it to 1. So this in decimal form is 2. And if I add 2 to 1, I get 3. So I'm really doing 80 times 3, which is 240. All right. If you do 200% of 80, you're going to get 160. But the problem is it's increased by that amount. 80 increased by 160 is 240. So again, a couple different ways to look at it. This is just how I do percentage problems, so I'm going to do it the same way. 1 plus 2 is 3. So increasing something by 200% is essentially the same thing as tripling it. All right, and our last level 2 problem. We have the right triangle, and so all I would do, we're dealing with 30, 60, 90 here, clearly. I'm going to just actually draw this out. So you're given some scrap paper. So make sure you just draw these out to keep everything straight in your head. We need B to be the right angle, so I'm going to do A, B, C like this. C is 30, AC is 32. And then I know that this is obviously 60. And then if I look at the reference sheet, the ratios tell me that it is X, X root 3, and 2X. So then I look at the one that they give me. So 32 has to be 2x, which means x is 16. So this is 16 root 3. And then I am going to find the area of a triangle. So that's 1/2 base, which is 16 root 3, times height, which is 16. And then I just have half times 16 times 16. You can use a calculator for that, and that is 128. Times root 3. So again, don't multiply by root 3. You can clearly see in the answers. We know it's D. Even just, looking ahead, if we go back to the beginning, if we were looking ahead, if you have a 30, 60, 90, then root 2 doesn't really make sense. So these answers were just kind of ridiculous to begin with. Okay. Now we get to our hard problems. Oh, my bad. This is still... another medium one. Okay, so here in number 19, we have a circle shown that has center O. If the measure of the angle DRE is 35 degrees, so DRE, this one is 35 degrees. What is the measure of EOD? All right, this one is pretty easy to do. But it involves a pretty specific theorem. This is the inscribed angle theorem. So an angle that's on the circle, as this one is called an inscribed angle. And here, with the angle that's at the center, is called a central angle. And what happens is they both open up to the same arc. So they have this relationship such that the central angle is always double the inscribed angle. And the central angle is the same as the measure of the arc. So essentially, both the central angle and the arc are going to measure 70 degrees. There, again, the math in it's super easy, but it's a very specific geometry kind of theorem that you have to remember. All right, moving on to number 20. So we have a standard deviation problem. And with standard deviation on the SAT, you do not need to know how to calculate it per se. You do need to just understand how it kind of works. So standard deviation is the measure of how spread out the data is. It's called a measure of spread. It really is just the kind of the average distance that each point is from the middle. So So we want to first be able to figure out the relationship between the means and standard deviations, but we don't want to have to do any actual calculations. So first, the means. Well, if you look at set 2, there is a lot higher values, right? There's way more 6s and 7s and 5s than there are here, and this one has a lot of lower values, more 2s, 3s, and 4s. So something that has higher values is just going to have a higher mean. So if we look at how the means are related, it says set 1 is less than set 2, so that makes sense for now. Here, the mean of set 1 is greater. That doesn't make any sense. The mean of set 1 is less than. Okay, so that still makes sense. And the mean of set 1 is greater than. So I get rid of those. So now we're down to just comparing their standard deviation. So here is kind of the idea. This actually, I believe I have this wrong. This is supposed to be a level 3 problem. So now what I have to do is kind of look at how the data is spread. But these two have the exact same spread. Now, one is right skewed and this one's left skewed and this is right skewed. But they're opposites, but they're spread out the exact same way. All right. So what's going to end up happening is the standard deviations are going to be equal to each other. So the mean of this one is going to be higher, but the way since they're exactly the same layout, like one of these 2, 2, 3, 4, and 3, this is the same, and they're the exact same values. So the mean of set 2 is going to be greater than the mean of set 1, but the distance that all the values are from that mean are always going to be exactly the same. So you're going to have the exact same standard deviation. Okay. All right, another level 3 problem. We've got 2 left here in our practice section. So number 21, the graph of the function shows how high the balloon is after x seconds. What is the best interpretation of h of x plus 3? So h of x is the height, and then we are adding 3 to it, so we're moving something higher. The balloon is released at the same height, and the height of the balloon is tripled each second. Well, that's definitely not true. I mean, we can imagine, like, if I were to move everything up, like, what's going to happen is I'm going to move everything is essentially going to get moved up by 3. So I'm really going to have, something that looks like this. So that doesn't make any sense. The balloon is released at a height of 3 meters. Well, that's not true. If you move it up 3, it's released at a height of 4 meters. So that one's wrong. The balloon is released 3 seconds later and at a height, well, it's not released any later. It's still released at the time that it's released. So again, that doesn't really make any sense. The balloon is released at a height of 4, and the height of the balloon increases at the same rate. Again, if we add 3 to it, the slope isn't going to change. So the answer choice is clearly D. All right, on to our last problem. What is the measure of an exterior angle of a regular hexagon? So I'm going to draw one out here just to get an idea. And let's remember that a hexagon has 6 sides. And there's 2 ways to do this. I think since it's a regular hexagon, all of the angles are the same, which means every exterior angle is the same, And exterior angles always add up to 360, So if I have 6 exterior angles, because it's a hexagon, and they're all equal to each other or congruent because it's regular, then all I have to do is 360 divided by 6, and it's going to give me 60. So that is the answer and the quickest way to get it. The other way is if you don't remember about exterior angles, but you do remember this formula, n minus 2 times 180, that would give you the sum of the interior angles. So that's 6 minus 2 is 4, 4 times 180 is 720. And then if you divide that by 6, you're going to get 120, which is one of the interior angles. And an exterior angle and an interior angle are always supplementary, so you're just going to be back at 60. So 360 divided by 6 is clearly the easiest way, but again, it just depends on what you know. So the best thing to do is to kind of know all the concepts, and then you can pick and choose which one is quicker. So n minus 2 times 180 is the sum of the interior angles. The exterior angles always add up to 360, no matter what. All right, that brings us to the end of the first module. So in the next videos, I will be doing the easy module for those that don't do as well in the first module, and then I will be also doing a full hard module for those of us that do very well on that first module. All right, hope that helped.